Welcome, my name is Carl and I am a Liberty University student, and I'm going to be going over the recursive sequence of a sub n plus 1 equals 1 over 1 plus 1 over the square root of a sub n, with a1 equaling 1. And we're going to go through showing that it is indeed a monotonic sequence. First, we're going to list out a few terms. So I got a sub 2 is equal to 1 over 1 plus 1 over the square root of 1. Because a sub 1 is 1. And that's going to give us 1 half, because 1 plus 1 is 2, so 1 half. A sub 3 is 1 over 1 plus 1 over the square root of 1 half. And that's going to equal 0.4142. And I'm just going to do a few more of these. So a sub 4, again, I'm just plugging in the previous term right here. Just a couple more and you'll see where we're going here. And then last one we're going to do here. Again, I'm just plugging in the previous result. As you can see, it is getting smaller, so we're at a decreasing sequence. We're getting closer and closer to 0.38 every single time we do this, which is going to lead us to part 2 of this. The monotonic sequence theorem does say it has to be bounded, and is it increasing or decreasing? As you just saw, it is decreasing, so what we're going to do is we're going to show that it's decreasing using mathematical induction. So I have a sub n is greater than a sub n plus 1. What we want to do is work on this to make it look exactly the same as our original. So we're going to start by square rooting both sides. This, as you recall, was flipped upside down, so 1 over the square root of a sub n. Remember, when you flip it, it changes the sign. I need to add 1 to both sides. I can do this because I'm adding the same thing to both sides. It doesn't affect the sign. And then finally, I need to flip this again because all of this needs to be in the denominator. So 1 over 1 plus 1 over square root a sub n is greater than 1 over 1 plus 1 over the square root a n plus 1. So by induction, I have a sub n is bigger than a sub n plus 1, which does show it is decreasing. From our previous result, we saw that a sub n plus 1 is going to be bigger than 0.38 because everything is coming down to 0.38. And again, I'm going to do the exact same steps I just did for this as that previous thing. I'm going to square root both of them. And then I'm going to flip it. So 1 over square root a n plus 1 greater than 1 over the square root 0.38. Add 1 to both sides. And then I'm going to flip it again. So 1 over 1 plus 1 over square root a to the n plus 1 is greater than 1 over 1 plus 1 over square root 0.38. That should be a less than there, I apologize. If you type this into your calculator, you get right back to 0.38. So I have everything condensing down to 0.38. For the final portion of this, I need to show that it works for any epsilon here. So for all epsilon greater than 0, there exists a capital N that's bigger than little n, such that a sub n is bigger than a sub little n. If that's true, I have a sub capital N is less than an L plus an epsilon, so it's just a little bit above L. If that's the case, I also know a sub little n is greater than L, which is greater than L minus epsilon. If I substitute all this in, I have L minus epsilon is less than a sub n, which is less than L plus epsilon. I want to get epsilon by itself, so I'm going to subtract L from everything here. So minus epsilon is less than a sub n minus L is less than epsilon. In order for this to work, I need L minus a sub n, so I'm going to do is I'm going to run negative through all of this. So epsilon greater than L minus a sub n greater than negative epsilon I'm going to rewrite that. Negative epsilon less than L minus A sub n less than epsilon. As you recognize, this is an absolute value right here. So the absolute value of L minus A sub n is less than epsilon. So I'm showing the limit as n goes to infinity of A sub n is equal to L. So I showed that it was bounded by 1 and 0.38, and it's decreasing, and it is monotonic decreasing. Thank you. I hope you have a great day and a great summer.